Assalamualaikum and very good morning to everyone. My name is Cikgu Ahmad Zaki bin Cik from SMJK Chonghua, Kelantan. Today, I would like to discuss about an essay question for STPM examination, term 1. The chapter involved in our discussion today is from chapter 9, that is Kinetic Theory of Gases. In this subtopic, in this chapter, it consists of 6 subtopics. There are ideal gas equation, pressure of a gas, molecular kinetic energy, the root mean square speed of molecules, degrees of freedom and law of equipartition of energy, and last but not least is last subtopic, that is internal energy of an ideal gas. So let us begin our discussion now. Before we observe the essay question involved, I would like to give you tips on how to answer essay question. Now, the first tip is you read through question given, then you underline the need in the question. Second, you relate the question with the chapter involved in the syllabus. Third one, you list down idea or formula and then you relate it to the question given. And here, drawing label diagram might help you to recall the idea. And last one, number 4, for calculation, you have to complete your answer with correct unit, because correct unit will give you marks. Without correct unit, you will deduct the mark. Now let us observe the example of question based on Kelantan G. China Model STPM 2021 for term 1. Right, here we have the question for 19A and 19B. 19A is explain how the molecule of gas at Z pressure, 3 marks needed. Second question, give the reasons why the pressure exerted by the molecule of a gas maintained at constant volume increases as the temperature increases. 3 marks. 19B, an ideal gas obey the equation P equal to 1/3 density mean C square, where P is gas pressure, rho is the density of gas, and mean C square is the mean square speed of the molecules of gas. Show this equation leads to the relationship between the mean translational kinetic energy of a molecule and absolute temperature of an ideal gas. Now, last question for question essay number 19C is state the law of equipartition of energy for 1 mark, and then calculate the internal energy of gas in a container of volume 2.0 times 10 to the power of -3 meter cube, contains 8.0 gram of helium gas at pressure 1.01 power of 5 Pascal. 3 marks given. So let us focus. Okay, let us focus on how to answer the question given. Remember to recall the tips given just now. It might help you to solve the question. Now, for question number 19A1, explain how the molecules of gas exert pressure. Remember, 3 marks. So, tips given is you might use drawing diagram. Okay, when you have drawing diagram, it may help you to recall the idea, to gain point, to achieve point, so that you can write it as an answer. Okay, how to answer? First, list the idea. Okay, number 1 is pressure comes from force over area. So you might think where the forces comes. Right now, forces involved, if you recall, it is involved of impulsive force. How to get impulsive force? From the molecules. From definition, impulsive force is the rate of change of momentum. And when you have momentum, of course, it requires velocity and also mass. Therefore, velocity of a gas comes from movement. The movement of gas molecules is in a random motion, yet it will create a collision with the wall of the container and collision among themselves. And because of the direction is changing, when collide with the container, the change of momentum occur. The molecule gas in a container is a very large number of molecules. So we have the point given there. So let us rearrange the answer from the point listed so that it can be a perfect answer. Now, if we rearrange the idea listed, answer would be the first one. You start with gas in a container have a very large number of molecules that move in random motion. That is your first point. And then each molecule possesses momentum due to its mass and velocity, because momentum comes from mass and velocity. Its direction is deflected. Okay, when it hits the area of a container, so it changes direction. So when the direction is deflected, means that it given rise to change of momentum over a certain time interval. In a short time interval, change of momentum happen. Therefore, this is where the impulsive force comes from. When strike the wall, what happens is a change of momentum per unit time will produce an impulsive force which acts on the area. So pressure is come from impulsive force over area. There you go. So that is the idea. That is the correct answer for question number 19A1. And the diagram you draw just now help you to get the answer. Okay, so let's move on to question 19A2. Right, for question 19A2, give the reason why the pressure exerted by the gas molecule maintained at constant volume. Okay, remember it maintained at a constant volume and then it increases as the temperature increases. So when we list the idea, we list the question, the point in the question, you need reason why pressure increases as the temperature increases at constant volume. So how to answer? Again, you list down the idea first. Okay, gain as many ideas as you want. Okay, number one, as temperature increases, the movement of gas molecule also increases. Okay, why? Because the velocity of the molecule increases. Thus, this would create change in momentum, and then of course, change in momentum would increases. The rate of collision also would be higher. Okay, the collision would happen in a rate higher. Thus, this will have the rate of change of momentum also will be higher. And because of the rate of change of momentum higher, it will create a greater impulsive force. And this greater impulsive force will be acting on the area of the wall. Right. What about the volume? The volume of the container is kept constant. Therefore, we can assume that the volume of the gas is also kept constant, because the volume of gas follow the volume of a container. So we have already completed our point. So let's rearrange the answer neatly. Okay, so to have the answer for question 19A2, when you write in a proper sentence, okay, first one is mean translational kinetic energy is directly proportional to the absolute temperature of a gas. The higher the temperature, the higher the kinetic energy. Thus, it will create higher velocity of gas molecule. And then the number of bombardment, the number of collision per unit time by the molecules against the wall would increases. And when the velocity greater, momentum created greater, change of momentum per unit time also will be greater, then it will create greater force on the wall, and then this will have greater pressure in the gas container. Okay, that is the answer for question 19A2. Now, for question 19B, an ideal gas obey the equation P equal to 1 over 3 rho mean C square, where P is a gas pressure, rho is the density of the gas, and mean C square is the mean square speed of the gas molecule. Show how this equation leads to the relationship between the mean translational kinetic energy of a molecule and absolute temperature of an ideal gas. 5 marks. Okay, so again, we note from the question P is equal to 1 over 3 rho mean C square. To become translational kinetic energy and to become an absolute temperature of ideal gas. Okay, so therefore we relate to kinetic energy and then we relate it to the absolute temperature. Therefore, we have to relate density to mass over volume. Why? Because mass, it will connect with the kinetic energy. You remember that kinetic energy will have half mv square, mass is needed there. And pressure with volume will connect to absolute temperature. Remember that PV is equal to nRT. So let us answer the question. Okay, from P is equal to 1 over 3 rho mean C square, change density to mass over volume. So the equation would be P equal to 1 over 3 mass over volume mean C square. Therefore, we rearrange PV is equal to 1 over 3 nm naught mean C square. So there goes our first equation. And also we note that PV is also equal to nRT for ideal gas equation. And then PV from N will become as N over Na, number of molecule over number of Avogadro, RT. And this will create our second equation. And therefore, when we have the first equation and we have the second equation, we relate it to each other. Okay, we do mathematically. Equation 1 equal to equation 2. So 1 over 3 nm naught means C square equal to N over NART. And then we rearrange, we solve the question nm naught means C square equal to 3 N over NART. And then for kinetic energy, okay, for kinetic energy is come from half mv square. So we relate to half nm naught mean C square, and this will equal to 3 over 2 N over NART. And therefore, kinetic energy equal to 3 over 2 kT. Okay, for the question C1, state the law of equipartition of energy. Now, how to answer? Okay, how to answer is you relate the definition of law of equipartition of energy. So the answer would be energy supplied to a system is distributed equally among all the degree of freedom, and each degree of freedom has its own energy, that is half kT. Okay, and then the last question for C2, calculate the internal energy of the gas in a container of volume 2.0 times 10 to the power of negative 3 meter cube contains 8.0 gram of helium gas pressure, that is 1.01 power of 5 Pascal, given as 3 marks. Now, we relate the equation with the correct equation. Okay, that is U is equal to, there is kinetic energy of one molecule equal to U over 2 times Na. So U is equal to F over 2 PV, and therefore degree of freedom is 3 over 2 times 1.01 power of 5 times 2.0 power of negative 3. So the answer is 303, and then the unit for kinetic energy will be joule. So the kinetic energy mean of one molecule is equal to 303 divided by 2 times the number Avogadro, that is 6.023 power of 23. So it will become as 2.52 times 10 to the power negative 22 joule. So that is the end of our discussion today. I hope what we observed today will bring benefit to us. Before I end, I would like to advise all students who take STPM examination, remember, it's not the teacher who can ensure your success. Even though you are given the best teacher in the world to teach you, the one who sit in the exam is you yourself. So change yourself and please be prepared for your examination. You determine yourself. With that, I pray that all of you who takes physics will achieve A for physics STPM examination. Thank you and good luck.